Good day guys, today we are going to be covering force diagrams as well as free body diagrams. We are going to be going over the differences of the two diagrams and we are going to be doing an exam example as well. Now fair warning, the exam example that we're going to do today goes hand in hand with the previous videos that I have set out, and that is the introduction to forces. So you have to watch those to understand fully what's happening today. Let's get into it. The first diagram that I'm going to be describing to you guys today is a force diagram. So let's read the definition. And guys, this definition is from the CAPS document, and you need to know a force diagram by this definition specifically. And it says that a force diagram is represented, or it is a representation of all the forces acting on an object drawn as arrows. So you guys can see over here we have an object. And on this object, which is the block in this case, we have various arrows that depict the forces that occurs on the diagram. So how is this different from a free body diagram? Let's go down and find out. So in a free body diagram, the object itself is replaced by a point with all the forces acting on it as arrows. So were I to draw the above force diagram in terms of free body diagram, what I will do is I will replace the block with a single dot and then just replace all the forces there as well. So I remember we had a normal force coming up, we had a force of gravity going down, we had going to the right the force applied, and going to the left opposite to the applied force we have the force of friction. So in a free body diagram, the object itself is replaced by a point with all the forces acting on it as arrows. And it's as simple as that. I'm not going to go into a lot of detail describing that. That's really simple. The crux or the hard part of drawing free body diagrams is looking at the specific situation and then deriving a free body diagram from that. But even then, it's still not really difficult. Right? Now, determining the resultant of forces is done as follows. Right? And this is the next thing we're going to go into. So in the prior videos, we described all the kinds of forces occurring. How do you resolve all of those forces? We do it by finding the resultant force. And the formula for resultant force is F resultant is equal to F1 plus F2. And a simple example of this would be, let's look at a block. I always like using a block, it's really simple. And let's say that this block has 5 kilograms of mass and it is on a surface. We have an applied force going to the right, so we have F applied, and let's call this F applied, or give this F applied a value of 20 newtons going east. Because we have an F applied, 20 newtons going east, we're going to have another force going to the left, and let's call this force the force of friction, because as we know, friction opposes motion. And let's give this frictional force a value of 5 newtons. Now if they were to ask you, find the resultant of the forces below, how would we go about doing this? Well, you can see that the formula is F resultant is equal to F1 plus F2. So we would quite simply say that the resultant force would equal F applied plus the force of friction. Now guys, within the exams, whenever you write down a formula, you get 1 mark if it is the correct formula for the problem. Now we're going to have to make a substitution. Well, before we move on, we have to also choose a direction that is positive. So choose a direction as positive, otherwise the math will not work. Alright, so in this case we're going to go with right being positive. So let's get into this. So we have our F applied, That's 20 newtons going east, and we know that going east or going to the right, it's positive. So we are going to substitute our F applied within this equation as a positive value. However, the force of friction goes in opposite direction, and that is 5 newtons in opposite direction. That's going to be minus 5 newtons. And then our F resultant will equal 20 minus 5, and that's going to give us 15 newtons of force. In which direction? That is going to be east. And that is a simple example of finding the resultant of forces. I need to give you guys another example, because in many circumstances we are not only going to deal with a horizontal example, sometimes we deal with vertical examples as well. Let's get into a vertical example. Let's say, for instance, we have a block, and this block has a force that is pulling it upwards. We are going to call that F applied, and F applied is equal to 30 newtons. The block is going to have a weight of 5 kilograms, and then naturally we are going to have a gravitational force pulling it down. Now I'm not going to give this gravitational force a value, because we know that the mass of the block is 5 kilograms. How do we find the resultant within this case? Well, it's quite simple. The first step, as you guys know, is always going to be writing down the formula. So F resultant is equal to F1 plus F2, etc. And we are going to replace the F1 with our F applied, and we're going to replace the F2 with our force of gravity. And then after this we are going to do something that's really important, and that is, as we've done in the previous example, choose a direction as positive. So let's go with up as positive. So with that being said, if up is positive, we need to now then find the force of gravity itself. Well, the force of gravity we know to be weight, and weight, according to the previous lessons that I have taught you guys in the videos introduction into forces, Fg is equal to W, which is equal to the mass multiplied by the gravity. But what is the mass of the specific block? 5 kilograms. And what is the gravity of the block? 9,8 meters per second squared. And in this circumstance we'll find the force of gravity is equal to 49 newtons. We can now very easily make the substitution to that equation. So we are now going to say, well, the F applied is 30 newtons, and in which direction does that occur? It occurs upwards. It's being pulled upwards. You guys can see it's going up, and the force of gravity is going downwards, and we said up is positive, so whatever the force of gravity is, if it pulls downwards, there's got to be a negative. And in this case the force of gravity is 49. We are going to substitute it into our equation as negative 49 newtons, and then the F resultant is going to equal negative 19 newtons. We can rewrite as the F resultant is equal to 19 newtons downwards. Now there's one important thing that I need you guys to notice over here, and what is that? We can only, for now, we can only resolve vectors slash forces in one plane of motion at a time. So what does that mean? If I'm busy with horizontal vectors, I add or subtract vectors within that horizontal field. If I am busy with vertical vectors, I add or subtract vertical vectors, or I add or subtract vectors within the vertical field only. I cannot add other vectors to a vertical vector. I cannot add a horizontal vector to a vertical vector, and I cannot add a vertical vector to a horizontal vector. Let's move down. So here